Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have been solving a lot of questions on generating context-free grammars and their past trees and leftmost derivation, rightmost derivation. Now let us see one application where we can use these grammars. We know how HTML works. In HTML, the code is usually matched using something called tags. So let me write one example of a tag. You can see that in HTML, every opening bracket is accompanied with a closing bracket. Now using grammar, we can construct an automated checking mechanism which will check is every opening bracket is associated with a closing bracket. So the requirement of our grammar is matching the parenthesis over here. That means every opening parenthesis should match with a closing parenthesis. Similar thing could be used in Java or C programming, in which we need to match braces. Let us say S is our start symbol. We have to make an assumption that we need at least one pair of opening and closing bracket, or else we may have an empty string, but now we are considering that we have one pair of opening bracket and closing bracket at least. You can see that this production will generate one opening bracket along with one closing bracket. But to have to close this, we need at least one elimination production. This particular production will help us in removing the S after required number of recursions. Now let us try to generate a string out of this grammar. Let us say we are generating a string which contains 3 opening brackets and 3 closing brackets. Let us try to find the leftmost derivation for this particular string. S is our start symbol. We need 3, so we start with the first recursive production. We have generated one pair of braces. Let us generate one more. You can see that we have produced 2 pairs of parentheses. We need now only one pair, so that for that we don't need the first production, we use the second production so that S is eliminated. Now we have constructed the required string. Using this grammar, you can easily see that we can verify the number of opening braces is equal to number of closing brackets. This could be used for any programming context such as HTML, Java or C, where we need to compare the number of parentheses at the opening to the number of parentheses at the closing way. Now let us try to draw the parse tree for the same string, because we have already know that if there is only one particular symbol in the derivation, leftmost derivation and rightmost derivation are going to be the same. Here we have S as only the one symbol, so the rightmost derivation would be the same. S is our start symbol, hence that would be the root of our tree. Using the first production, we can produce the first pair of parentheses. We need one more pair of parentheses, so we use the first production again. We need only one pair now. If we reuse the first one, then we will not be able to eliminate the S in that particular production. Hence, we will eliminate using the second production. You can see that the yield of this parse tree would be opening braces followed by 2 more opening braces followed by 3 closing braces. One over here, the other one here, and the third one, and we are reaching at the start symbol. This is giving us the required string. I hope this example give you an overview of where the grammars and automata concept could be used in programming context. Thank Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.